So we're looking at our first section, first chapter of our textbook, and we're going to be solving linear equations. I just mentioned that there are some topics in here that we have seen before in the past, and so those topics, we're going to try to move through those faster so that we can spend more time on those subjects that you hadn't seen before in your math class. And so learning objectives, this is what I expect you to know after going through this section and doing your homework. So you should be able to solve a linear equation. Hopefully you should also be able to identify what a linear equation is. You should solve equations that lead to linear equation. So maybe when we started looking at the equation to solve, it wasn't linear, but as we worked through and progressed through solving for the solution, it became a linear equation. And then you should be able to solve problems that can be modeled by linear equations. So that's what we're expected after this lecture. So there are different types of equations that you can find when you are working and trying to solve for a solution. So one thing that can happen when you're doing that is that you might get some contradiction. So for instance, what if I had the example 5 plus x is equal to 6 plus x. And so I went through here and I went to go solve my equation. So simplify both sides of the equation, get variables to one side, constants on the other. And so if I did this and went through to solve for this, I notice when I subtracted x on both sides of the equation, I get 5 is equal to 6. Well, I know 5 is not equal to 6. So here's a case where I get a contradiction. And so if this is the case, then we know that there is no solution. So your equation might be a contradiction. You might get one that is an identity. So for example, of an identity, let's look at, I don't know, I'm trying to pull some up in my head. So let's look at 5 parentheses 2 plus x is equal to 10 plus 5x. And so when I work through this problem here, simplify both sides of the equation, and we'll go through the process and discussing this in a second, solving equations. So distributing, I get 5 times 2, which is 10, plus 5 times x is 5x equals 10 plus 5x. And when I go in here and I try to get x's to both sides, so if I subtract 5x on both sides, I get 10 is equal to 10, which is a true statement. But any number I plug in for my value of x here is always going to come out a true statement. And so this is a case of an identity. And so in this case, we have an infinite number of solutions. Any number works. For our variable, in this case, x. And then the last type of equation that you can get when you're solving, you'll find out that it's a conditional equation. So if I'm looking at a conditional equation, so maybe let me write up here. So how about 2 times 5 plus x is equal to x. So when I go through and I solve this, I'm going to get a solution, more solutions depending on what type of equation. So if I distribute my 2, I would get 10 plus 2x equals x. If I subtract 2x on both sides, I get 10 is equal to negative x, because x minus 2x is negative x. Divide both sides by my -1, I get x is equal to -10. And so it's conditional. There's only one solution for this equation, -10. So 3 different things could happen as you go through and you solve for your variable in an equation. So we'll be working with linear equations. Just kind of want to get some more room. And so linear equations can be written in the form of this ax plus b equals 0. In this case, we're saying that this variable a is representing a real number. We're saying that b is also a real number, and that x, in this case, is the variable. So this is sometimes called the standard form of a linear equation. Notice in here that we have to put a stipulation that a cannot equal 0. So do you guys know why a couldn't be 0? Because if a is 0, why would that not be a linear equation? Well, if a was 0, right, you get 0 times x plus b equals 0. And so this now is not linear because we don't have that variable x in there. We just have some constant b, which is 0. Linear equations, we'll talk about degrees of polynomials. Linear equation, the degree of our variable is 1. The exponent of that variable is 1. Okay. So let me know if I need to slow down. Sometimes I'm going to bring in where I have stuff typed out so I don't have to write it out. But I can slow down if you need to write something in. Okay, so what does it mean? So let me just kind of read through this really quickly. But it says to solve an equation means to find all solutions of an equation that makes it true. Okay, so we're going to be solving equations. Solutions can be written in set notation called a solution set. So for instance, up here, when we have found that x was equal to -1, we can say that x is equal to a set notation. You have these, I call them curly brackets, and a -1. One method for solving an equation is to replace the original equation by a succession of equivalent equations. Sorry, I think I read that wrong. One method of solving an equation is to replace the original equation by a succession of equivalent equations. Equations having the same solution set until an equation with an obvious solution is obtained. So as I was solving these equations back up here, this 5 plus x equals 6 plus x, an equivalent form was 5 or equals 6. They both don't have solutions. So we're basically taking we're rewriting equations to different equations that have the same solution. Okay. So to do this, to change these equations, to simplify it down so that we can find the solution to the original equation, we're going to use multiple properties from previous courses. These can help us with this, including the addition and multiplication properties of equality, along with the distributive property. So basically, what all that's saying is we're going to use the following properties to solve these linear equations. If we know that A is equal to B, then we have this addition property that says then A plus equals b plus, as long as we're adding the same thing to both sides of the equation. So let's say c. It's equivalent. So what we do to one side, we got to do to the other side. That works for addition or subtraction. So plus or minus. But also we can do this with division. So if we have a is equal to b, or multiplication, so we can do a times c is going to equal b times c. Multiplication is just the same thing. I'm sorry, division is just the same thing as multiplication. It's just multiplication of the reciprocal of what you're going to multiply. So for instance, you can do a times 1 over c, which is the same thing as saying b divided by c. Okay, so you've been using those properties all along as you've been going through and solving equations. So process of solving linear equations, and I was kind of talking that through as we were looking through those problems before. But the process of solving linear equations, first thing that you want to do, if you have any fractions, best thing to do is to clear them. For some reason. So if you have any fractions in your equation, then you're going to find what the least common denominator is of all the fractions within the equation, and we can clear those fractions by multiplying both sides of the equation by that least common denominator. You got to be careful though, because if there's variables that are in the denominator of the fraction, then we should identify the values of the variables which will make the denominator equal 0. Because we can't divide by 0, those values are not going to be in our domain. So we need to avoid those numbers. So find out the values. If you have a variable in the denominator of your original equation, find the values which set the denominator equal 0. And we're going to exclude those from our domain. Make sure none of our answers give us that as a solution. If it does, those are extraneous solutions and they don't work. Okay, so it looks like my numbering got off, but that was 1. So this is 2. So simplify both sides of the equation after you've cleared any fractions, if there was any. If there wasn't any, then you're going to simplify both sides of the equation. So you're doing that by clearing any parentheses. So using your order of operations, distribution, combining like terms. And so once you've simplified each side down as far as possible, then you're going to use the first 2 facts above to get all terms with the variables on one side of the equation. And all constants on the other side of the equation. Doesn't matter which side you decide to bring variables over and which side you bring constant over. You should get the same result at the end. And so once you've gotten all the variables to one side of the equation, all your constants to the other side of the equation, if the coefficient of the variable is not a 1, then we want to go through and divide both sides by that number so that we can make it a 1. So note that we usually just divide both sides of the equation by a coefficient if it is an integer, or multiply both sides of the equation by the reciprocal of the coefficient if it is a fraction. And then 5, verify your answer. So it's possible that your solution doesn't work. Maybe you missed out looking at the denominator and it had a variable there, and that was a value that made it denominator 0. But this is the final step and the most often skipped step, yet is probably the most important step in the process. With this step, you can know whether or not you got the correct answer long before your instructor ever looks at it. We verify the answer by plugging in the result from the previous steps into the original equation. It is very important to plug into the original equation, since you may have made a mistake in the very first step and led you to the incorrect answer. Also, if there's fractions in the problem and there were values of the variables that were given division by 0, recall the first step, it is important to make sure that one of these values didn't end up in the solution set. It's possible, as we'll see an example, to have these values show up in the solution set. Okay, so that was just kind of talking about some different terminology, different types of equations that you can have, and then the steps and processes of going through solving linear equations. So let me pull up some examples. And before I do that, let me see if there's any questions. So I'm going to pause the recording for now, and I'll come back and let you know if there were questions and answer them. Okay, so there was a question, great question. And the question was a reminder of what a coefficient is. And this just is a great reminder to just let you know how important it is to know, the terminology behind what we're doing. Because if I start saying stuff and you don't understand what that term means, then it kind of jumbles things up. And there's a great discussion that we guys are going to do a little later in this course on, are you speaking a foreign language? Because there's some things that you guys might be an expert in or know some information about, maybe some music or something, and terminologies that the layman person wouldn't know about what you were talking about if they heard you speaking about it. So, and just importance of knowing what things mean. So the question was, what is a coefficient? And so when we're dealing with equations or expressions, we have coefficients, constants, and variables. Coefficients, these are the numbers attached or being multiplied to the variable. The constant, that's the number without a variable. And our variables, those are usually represented by our letters that we're solving for. So for instance, if I did 2x minus 6 is equal to 0. In here, my coefficient is going to be 2. My x, right, is my variable. I actually have 2 different constants here, and you need to be careful with constants. You want to carry the sign. And so in this case, my constant is a -6. We actually even have a constant over there of 0. So you have an example in front of you. It's 5 minus 2 times the quantity x plus 4. And that quantity is equal to 3 times the quantity x plus 4. So when I'm doing examples in class, my suggestion is that you try to do the problem too. Maybe I'm going to go a little slower because I'm trying to explain things, but if I'm not doing like a try it where I just say, go ahead and try this, and then we discuss it, I would try to do the problem. And then if you got stuck somewhere and I'm working through it, then you can see how to do it or ask questions. If you were watching this video and we're in class where it's live, then you can always pause it first, try it, and then watch through the steps. Okay, so this problem that is in front of me, there's a couple of big errors that I could see where students would make here and would get the wrong answer. So this is a linear equation. First thing that we do is clear any fractions if we have them. We don't have any fractions. Second thing that we want to do is we want to simplify each side of the equation. I think of this as order of operations. I see parentheses in there. I would look at my parentheses, notice that x and 4, x plus 4, those are two different terms, but they're not like terms and I can't combine them. And then I would notice that those numbers in front of the parentheses, there's no addition or subtraction sign. And so that means that this is multiplication between that 2 and that, or actually in this case, I'm going to distribute -2, and this x plus 4, and this is multiplication here. And so recall, multiplication comes before any addition or subtraction. And so in this case, it would be a common error that students could want to do 5 minus 2 first. But that subtraction and multiplication comes before that if we're talking about order of operations. Be careful when you're distributing, you want to distribute the sign. And so in this case, because there's a minus in front of that 2, we're going to treat it like -2, and we're going to distribute the -2 to each term. And so doing that, bring down my 5. I haven't done anything with it yet. Distributing my -2, I get -2x. -2 times a +4 gives me -8 equals. And then on the right-hand side of the equation, I am again distributing. There's no sign in front of the 3, so it's positive. So distributing the 3, I get 3 times x plus 3 times 4, which gives me 3x plus 12. After you do any distributing, you want to see if we have any like terms. Like terms, they have to have the same variable in that term raised to the same power. Or constants, they don't have any variables, those are like terms. And so in this case, we have this 5 minus 8. Well, 5 minus 8 is -3. Let's bring down that -2x is equal to 3x plus 12. Okay, so both sides are simplified down as far as possible because this is a linear equation, and depending on what type of equation we have depends on how we proceed. And so since this is a linear equation, this is where we want to get variables to one side, constants to the other. So terms with variables, we have this -2x and a 3x. They're on different sides of the equation. So whatever we do to one side, we want to do to the other. So let's actually add 2x to both sides. So since I'm moving all my terms with the variables to the right, that means I'm going to move all my constants to the left-hand side of this equation. And so let's get rid of this 12 on the right-hand side. And so we could subtract 12 on both sides. Okay, so we have a -3 minus 12, that's -15 is equal to 3 plus 2x, which is 5x. So we've gotten the constants to one side, variable terms to one side, both sides are simplified down as far as possible. We want x equals, but not 5x equals. So we can either think of this as dividing both sides by 5 or multiplying by 1/5. And so if we divide both sides by 5, I just tend to like my variable when I write it out what the solution is on the left-hand side, but it's the same thing. X is equal to, well, -15 divided by 5 is -3. So that's my solution. This is a conditional equation because I got a solution back. And then if we were to check it, we would be plugging it back into the original equation that we started for. And wherever we saw an x, we would be replacing it with -3. So let's just check it really quick. I'm normally not going to do this, but 5 times or -2 times, I see an x here. So I'm going to replace that x with a -3. So instead of x, I'm going to write -3 plus 4 is equal to 3 parentheses. I see an x here, so replace it with what we got for our solution, -3 plus 4 in the parentheses. So I'm not sure if that's true. I just want to show it, so I'm putting a question mark in front of it, or above that equal sign. Order of operations, work inside parentheses first. So we have 5 minus 2. Bringing down, I have -3 plus 4 is 1. So 1 inside the parentheses is equal to 3 times. Working inside the parentheses here, I'm -3 plus 4, which is 1. Multiplication comes before any subtraction. So we have 5 minus 2 times 1 is 2. Is this equal to 3 times 1, which is 3? Yes, 5 minus 2 is 3, and that is equal to 3. So it did work, and we found the correct answer to that original equation. X equals -3. So our next example, we have in the numerator x plus 4, and that's all over 2. And then we have another grouping. So in between that grouping, we have a plus, and then in the numerator, x plus 1. That x plus 1 is all over 3, and then that is all equal to 10. So looking at this example, it's linear. I don't have any variables in the denominator, but I do have some numbers down in the denominator. So there's nothing that I have to exclude because there's nothing that's going to set that denominator equal to 0. I want to clear the fractions. It just makes life so much easier to get rid of those fractions. And the only reason I can clear these fractions is that I'm dealing with an equation and not an expression. The difference between an equation and an expression is an equation we're solving to get some value for your variable. Where an expression, this might not have an equal sign here, this might have a plus sign here. If there was no equal sign here, this is an expression and we would just be simplifying things down as far as possible. And we can't clear the fractions in this case because in this case where it's an expression, there's not two sides of the equation. So we're not doing this things to both sides to keep it equivalent. Okay. So I can clear the fraction because what I originally had is an equation. So I look at all the values in my denominator. I see I have a 2 and a 3, and I think to myself, what is the common denominator, least common denominator? And looking at 2 and 3, that least common denominator is 6. And so what I want to do is I want to multiply both sides of my equation by 6. And the reason I choose 6 is because I know that both of my denominators go evenly into 6. And so technically we need to distribute the 6 to each term. And a lot of times I won't write that step out, but when I'm first starting to show problems, I do like to write more things. So I have 6 times that quantity, x plus 4, all over 2. Then I have that plus 6 times that quantity, x plus 1, all over 3, equals, well, 6 times 10, I can simplify that, is 60. So notice that because this is multiplication in between this 6 and that fraction, we can simplify this 2. 2 goes into 6 3 times, and 3 goes into 6 2 times. So let's now distribute. So now it's really like 3 distributing to this x plus 4. So if I distribute 3 to that x plus 4, I'm left with 3x plus 12 plus, and now let's distribute that 2 to the x plus 1. And so we get back plus 2x plus 2 is equal to 60. So we've cleared all the fractions now, makes our life a lot easier, less room for error as we're going through and solving. So we want to simplify both sides of those equations. We do have like terms on that left-hand side. So combining my 3x plus my 2x, that gives me a 5x, plus my constants, 12 plus 2, that gives me 14, is equal to 60. So since I only have a term with a variable on the left-hand side, I'm just going to keep my variable on the left and move and get that 14 to the other side. Get rid of the 14 on the left. That means I have to subtract it. And subtracting 14 on both sides would leave us with 5x is equal to 60 minus 14. So that's going to give me 46. And I want x equals and not 5x equals. So we want to divide both sides by 5. So we get x equals 46 fifths. So any questions on that one?
Yeah, I have a question. Do you want most of your answers in fractions, or would you prefer them in decimal if we can break it down?
Okay.
Decimal.
Good question. So it really kind of depends on what you're looking at. Sometimes just looking at what you're working with. So like if this problem had decimals in there, as part of the numbers or coefficients or constants were decimals, I would probably have my answer as a decimal. It really doesn't matter if I don't ask. If it is a fraction though, make sure that it's reduced down as far as possible. So if 46 and 5 both had a common factor, I would simplify that down. They don't. This is a mixed number, or it's an improper fraction, so I could write it as a mixed number. And unless I ask you specifically, I would give you credit either way. But for your homework, you might want to look at, a lot of times, my math lab will be specific on how they want the answer. But if it isn't specific, it should also take it both ways and not mark you down wrong.
Okay, thank you.
Yep. And so I could rewrite this as a mixed number. 5 goes into 46 9 times. So that's 45. And I have a remainder of 1 over my denominator, 5. And to me, that mixed number makes a lot more sense than 46, thinking of what 46 fifths is. Okay, so the next example is x all times the quantity 2x minus 5, and your parentheses is equal to parentheses 2x plus 2, and your parentheses all times the quantity x minus 3. Okay, so we want to solve this equation. So we want to look at both sides. We want to simplify it down. There's no fractions, so we're good there. So it looks like we have some distributing to do. So x times that quantity 2x plus or minus 5. Distributing that, we would get back 2x times x is 2x squared minus x times 5. So 5x is equal to, because we have binomial times a binomial. Binomial means 2 terms. So 2 terms times 2 terms. And so we want to distribute here. So 2x needs to be distributed to each term in the first parentheses. And then our positive 2 needs to be distributed to both terms in the second parentheses. Binomial, you can, if you wanted to, you've probably heard the term FOIL before, but that only works for 2 terms times 2 terms. So I don't tend to use that terminology FOIL. Anyway, so 2x times x, that gives me 2x squared. 2x times negative 3, this is minus 6x. And 2 times x gives us plus 2x. And 2 times negative 3 is minus 6. So rewriting the left-hand side, those are not like terms. 2x squared minus 5x, because of terms are not raised, or those variables x is not raised to the same power. On the right-hand side, we have 2x squared. Here we have a minus 6x plus 2x, or negative 6x plus 2x. And so that gives me minus 4x minus 6. So right now, this equation that we're dealing with is quadratic. And so we actually deal with solving quadratic equations differently than how we would solve linear equations. That's where we want to get everything to one side and set it equal to 0. The thing is, as I go through the process of solving this and I subtract 2x squared on both sides, this is gonna, the 2x squares will cancel. And so then we would be left with this negative 5x on the left is equal to negative 4x minus 6. And so what had started out to not originally be a linear equation, as we work through the process, has become a linear equation. And so again, we solve linear equations differently than quadratic, and that's where we got the variables to one side, constant on the other. So adding 4x to both sides, we have negative 5x plus 4x is a negative 1x. I don't have to write the 1 there. So negative x equals negative 6. Divide both sides by 1, negative 1. We get x is equal to positive 6. Questions on that one? So let's look at an equation that when we're starting, it looks like a rational equation. So if we had x all divided by x minus 6 plus 1 is equal to 6 all over x minus 6. Okay, so here's a case where we have a rational equation. So we have fractions within the equation, and within the fractions, we have a variable in the denominator. So that's what it means to be a rational equation. We don't want fractions. It is an equation, so we can cancel the fractions. And I look at this, and both of our denominators are x minus 6. So I know my LCD is equal to x minus 6. Just going to put it in parentheses. And so we're going to go to both sides of the equation, and we're going to multiply by x minus 6. Be careful here because it has to be to every single grouping on each side. So I should have parentheses or brackets around this left-hand side. On the right-hand side, we're also multiplying by x minus 6. Before I go through and start simplifying, let's also write here before we start what x cannot be. And so we do have a condition here that x should not be equal to positive 6, because we can't have anything making the denominator equal to 0. It's undefined to divide by 0. Okay, so we want to distribute that quantity x minus 6 to each grouping on the left-hand side. But when we distribute it to that first grouping, that x minus 6 cancels, right? I'm just going to write it this time, but normally, again, I wouldn't do this all the time. So distributing it, and then on the right-hand side, these x minus 6, they both have the same factor in the numerator and denominator there. We chose it to be that way so that it would cancel. So this is equal to 6. Okay, so the first grouping, we have that x minus 6 times the fraction x all over x minus 6. So the x minus 6 cancels. You're left with this x plus, well, 1 times anything is just that anything. So let's just drop the parentheses and write x minus 6 equals 6. Okay, we like terms on the left-hand side, 1x plus 1x. So that's 2x minus 6 equals 6. Get the constants to one side. So adding 6 to both sides, we get 2x is equal to 12. Divide both sides by 2, I end up getting x is equal to 6. Well, at the beginning, I stated that x could not be 6. If you didn't state that, then go back to your original equation and always make sure that if you had variables in the denominator, that's not making that denominator 0. So x can't be 6. So in this case,
Why can't x be 6? I missed that part.
because our original equation has x minus 6 in the denominator. And so if I plugged back 6 in the denominator, I get 6 minus 6, which is 0. And there's nothing I can divide. There's nothing I can multiply 0 by to get back 6. So we can't divide by 0. It's because
Okay.
that's undefined.
So we just need to like keep that in mind if we do a homework problem that has like an example like this.
Exactly.
Okay.
So you need to, if you have, when you ever start an equation and you have variables in your denominator, you always have to be careful and make sure that solution or what your answer is doesn't make that equal to 0. And so when I was showing you guys the homework program earlier today, when we were looking at one problem, there was, x equals and then the curly brackets, and you could put in your answer, but the next thing below was there a bubble which said no solution. And so that's the case where you would have to put in no solution there. Okay, so we're going to look at a word problem. And as we go through the word problem, I'm going to kind of just talk through how you should be writing up word problems when you're doing homework, or especially when you're working on an exam that has a word problem. And so the following problem says, Shannon, who was paid time and a half for hours worked in excess of 40 hours, had a gross weekly wages of $608 for 56 hours worked. What is her regular hourly wage? Okay, so a lot of times when you're reading through word problems, it's helpful to read through multiple times just to kind of figure out what's going on. Here, I noticed my question, it's asking what is her hourly wage? And so that's what I'm going to choose my variable to represent. So it doesn't matter what variable you choose. I just tend to like X a lot of times. And so part A is choosing what your variable you're going to use and explaining what it represents. And so in this case, X is equal to Shannon's regular hourly wage. So the next step of working through a word problem after you define your variable is setting up your equation. There's going to be enough information in there that we can set up some sort of an equation so that we can figure out what our variable is. Let's find the solution. So we know that she is paid time and a half for hours worked excess over 40 hours. And we know that she's worked 56 hours. I'm sorry, 56 hours. So technically, we know that for the first 40 hours, right, she's going to get her normal wage of X dollars times X dollars an hour. Plus, we know that she's also going to get paid extra for anything over the 40 hours. Well, I know that I can get that excess time by looking at the total number of hours she worked, which was the 56, minus the 40 hours that she is getting paid her normal wage, times, but she's getting, it says, time and a half. So she's getting 1.5 times her hourly wage. And so 1.5 of her hourly wage, which is X, is equal to, and we found out that she had a total amount of $608. Instead of writing 1.5, just because we were dealing with fractions before, this is the same thing as 3/2. me just write it as 3/2 here. Either way, you're going to get the same result. Okay. And then part C is your solution. And so over here on the left, we're just going to take our equation and we're going to start solving for our solution. And so my equation I have is 40x plus, normally I would write this above here, but we're running low on the time. So I'm just going to simplify in here. So 56 minus 40, I know is 16. So plus 16 times 3/2 x is equal to 608. I don't really need to clear the fraction because I can simplify here, right? 2 goes into 16 8 times. So really I have 40x plus 8 times 3, so 24x is equal to 608. So 40x plus 24x, that's 64x, is equal to 608. And then I want to divide both sides by 64. If you're working on your homework, I'm okay with you using the calculator there. If for some reason I didn't allow you to have a calculator on the exam, you should be able to do this. Well, 64 doesn't go into 60. You want to guess about how many times it goes into 608. Let's try 9. 9 times 4, that's 36. 9 times 6, that's 54, plus 3, that's 57. We're going to subtract this off. It's 32. Put my decimal. This is where I think decimals would make more sense. Bring down my 0. So 64 goes into 320 5 times. 5 times 4 is 20. Carry my 2. 5 times 6 is 30, plus 2 is 32. So I get here that x is equal to 9.5, which makes more sense because I'm talking about money and you want to make sure you put your units when we're talking about word problems. So x is equal to $9.50. And so that's how you would kind of set up your word problems. You have these 3 values. A, set up your variable. What does your variable represent? B, set up your equation. C is your solution using units when we're talking about word problems if it's needed. And then on the left, I normally just show my work here.